Okay, today we are going to talk about reviews of properties of exponents. Okay, so you guys should know most of these, but we'll just go over them super quick. So the first thing I want you to notice is that if you have the same base and you're multiplying, you're going to add the exponents. So same base, multiply, you're adding your exponents. So we should have this base with 5 plus 7, which is x to the 12th. Now, if you have the same base and you're dividing, you're going to subtract the exponents. So we do have the same base and we're dividing, so we're going to subtract the exponents. So it'd be x 10 minus 3 equals x to the 7th. Now here's the different part of this. If we had more on the bottom than we have on the top, we would get a negative number right here, right? But we never leave negative exponents, and that's going to go to another property that we have. That's why whenever I do this, I usually just ask, oh, who has more and how many more? So here the top had more, and it had 7 more, so we left 7 more on the top. Okay, the next example is power rule. So this basically says if we have a base that already has an exponent and we raise it to an exponent, we're going to multiply. So we have a base that's raised to an exponent, and then we'll raise that to an exponent, so we're going to multiply. So this is x to the 3 times 5, or x to the 15. Now, I don't need you guys to show this section. I mean, you could just do that in your head. I'm just showing you because this is a video. Similarly, the power of a product rule means that if I have two bases, each with an exponent, and I raise both of them to the w, or to an exponent, we're going to multiply that w by both of the exponents. So here we have 2 to the 4th power, 3 to the 4th power. So we will have x to the 2 times 4 and y to the 3 times 4. So this is going to be x to the 8, y to the 12th. Same with the fractions, right? Power of a fraction. So we have these two bases and each one has an exponent. And then we raise the whole thing to an exponent. So we are going to multiply their exponents. So this is base and this is a base. Now here's the different part of this. This is just a 1, right? If there's nothing there. So when we multiply these exponents, we will see x to the 1 times 2 over y to the 3 times 2. So we will get x squared and then y to the 6th power. Now, this is pretty important because this is something a lot of people miss, but it's basically what happens when we have a 0 exponent. So remember back up here, I said when we have more on the top, we will get the variable will stay on the top. If we had more on the bottom, the variable would stay on the bottom. But when we subtract things, let me erase that. When we subtract things and we make a 0, that means we have the same on the top as we have on the bottom. So we think about that. If I had a to the 4th on the top and a to the 4th on the bottom, we would get a to the 4 minus 4, right? Which is 0. But can you see how I have the same exact on the top as I have on the bottom? Well, that means that we're going to be making a 1, right? Because anytime you have exactly the same number, whether it's y over y, that would make a 1, or 10 over 10, that would make a 1, right? So whenever we have the same exact value on the top and the bottom, we're making a 1. And that's what that 0 exponent means. So you can see how this 0 is applied to both of these, right? So we essentially have x to the 4 times 0 and y to the 3 times 0. So that means each one of them has a 0 exponent, which means this is just 1 times 1, or 1. We could also think of it as this being the base and raising it to the 0 power. So we could have immediately just went to 1. Okay. Now, we just talked about this. If we have a negative exponent, we don't keep it. So if it's on the top, it goes to the bottom and becomes positive, right? If it was on the bottom, it would go to the top and become positive. So basically, negative exponents go and become positive. So this is essentially over 1. So this is a negative exponent. So it's going to go, it's on the top, so it goes to the bottom and becomes positive. Why do I keep wanting to write an equal sign there? So now we don't have anything left on the top, so that's what it would look like. Now, on the next one, our negative exponent is on the bottom, just like our negative exponent here was on the top, this one's on the bottom. So it's going to go. So we have a top and a bottom. The 3 stays because there's no exponent on it, and the x to the 5th goes to the top. Now, when we don't have anything in the top or the bottom, we put a 1, but we don't really need to keep the 1 when it's on the bottom. So that would just be our answer. We also have to remember what a fractional exponent means, okay? So what a fractional exponent means is you have a base, and then you have an exponent over an index, right? So you can see this is the exponent, and then this is the index. Okay, so we see a fraction exponent, right? So we see that fraction exponent, and we're like, okay, that means we're going to have a radical, and this is our base, the top is our exponent, and the bottom is our index. Now we could have also written this like this, same idea. Okay, so how do we go backwards then? Well, we see a radical, so when we see the radical, we know that we have a fraction exponent, right? So this is going to be x to the, you can see how the exponent here is 1, and the index is 3, so it's x to the 1/3. Okay, so those are the basics. Let's go do some additional examples that might look a little bit different. Now, this is multiplication, and in multiplication, it's commutative. So we can really, if we wanted to, we don't have to do this, we can rearrange everything so their like bases are next to each other. We don't really have like bases in the numbers, but then we also have x to the x cubed and x to the 5th power. And so because we have the same base, we will add those exponents. But so we get negative 12 here, and then we have x to the 3 plus 5, which means we have negative 12 x to the 8th power. And that will be our answer. Do you have to show your work on this? Not really. I'm just showing you so that you know what's going on in my brain. Okay, so now that we have an exponent on the outside of a fraction, this exponent needs to go to every exponent. Well, the 3 being a base has an exponent 1, and the 4 being a base has an exponent 2. So basically what we have is 3 to the 1 times 2, x to the 5 times 2, over 4 to the 1 times 2. So this would be 3 squared x to the 10th over 4 squared. Well, we have to simplify that a little bit. So we get 9x to the 10th over 16. And that would be our solution. Okay, let's do another one here. Again, we have fractional exponents. So we're going to look at all, we have a fraction with an exponent. Our exponent is 2, right? So that's going to apply to all of these exponents. So let's rewrite it. 2, 1 times 2, x to the 3 times 2, 5 to the 1 times 2. Now, before you raise an exponent, you would want to like clean the house a little bit. If there was anything in here that you could simplify, do that first. We don't have anything that we could simplify, so we keep going. So this would be 2 squared x to the 6th over 5 squared. So again, we're going to end up with 4x to the 6th over 25. Okay, last one. Now, remember when I said clean inside the house? So let's look inside the house first. Well, we can see that we have a r on the top and an r on the bottom. But we also see that we have negative exponents. So let's just clean this up first. We have r cubed, y squared. We have r. All those are positive exponents, so they stay. But this guy is a negative 3, so it's going to go. Okay? So as we clean this up, and obviously I'm doing this in my brain, but I would be doing this. I could do this on as work. So once we have a negative exponent, I'm not going to keep the negative exponent. Hold on. We can change that to a positive exponent, or we can clean the inside up. I'm going to go ahead and wait for the negative exponent to fix, and I'm just going to go to the bases. Here's r. We have an r on the top and the bottom. Who has more? The top. How many more? 3. Now we could have just done r to the 3 minus 1, seeing that we got a positive 2, right? Then we would have had r squared, and it would have stayed where it was because it's a positive. On the top, we have our y squared and y cubed, so we have y to the 2 plus 3, so this is going to be y to the 5th, and it's going to stay, and we don't have anything left on the bottom, so that's what we have. Now, because we have this negative 1 and it's applied to the whole thing, everything goes. So we would have the 1 on the top now, r squared on the bottom, and the y to the 5th on the bottom. And now we have a positive 1 exponent, which means we know that it's just itself. Now, are there different ways to do this? Yes, right? We could have just applied this negative 1 to all of these exponents, and then all of these exponents, and then made everybody go. We could have just switched everybody and then cleaned the house. But with negative exponents, sometimes we just need to worry about what's inside first and do that negative 1 at the end. That's what I suggest, but you don't have to do that. Okay, take care.